Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is cyclohexane 1,2,4-triol, 3 of groups on a cyclohexane ring. The product is 4-oxocyclohexane 1,2-diol. The OH at C4 is oxidized to a ketone, while the vicinal diol at C1, C2 is preserved. Moving on to the next step. We need to selectively oxidize the single secondary alcohol at C4 while leaving the vicinal diol, C1, C2 untouched. The approach is I. Protect the vicinal diol, C1, C2 as an acetonide, cyclic ketal using Me2CoH+. This selectively protects the CIS 1,2-diol as it can form a 5-membered cyclic ketal, leaving the C4 OH free. 2. Oxidize the free C4 OH to a ketone using KMnO4, used as an oxidant for secondary alcohols under appropriate conditions. 3. Remove the acetonide protecting group by acid hydrolysis with H3O+ to regenerate the free 1,2-diol. Moving on to the next step. Option B. Me2CoH+, KMnO4, H3O+ follows exactly this sequence. Protect the diol as acetonide, oxidize the free alcohol with KMnO4, then deprotect with aqueous acid. And for the final step, A. Uses KMnO4HO as the last step, which would cause overoxidation or open the diol under basic conditions. Also, the order is wrong. C. KMnO4 now 4 is not a standard reagent combination for selective alcohol oxidation. NaO4 is used with OSO4 for diol cleavage, not here. D. KMnO4 NaO4 at the start would cleave the vicinal diol. Periodate cleaves 1,2-diols, destroying the desired diol before protection. Option B is the only sequence that correctly protects the 1,2-diol first, selectively oxidize C4 OH, and then deprotects. Therefore, the correct answer is B. Therefore, the correct answer is option B.